Hello! Oh well, this time in Fredrik machining. We are going to make a block for some hydraulic hoses to be attached into. And well, this is quite a heavy one. So yeah, okay. It's all about milling and maybe drilling and then tapping a few threads into that. Okay, let's start with it. So, now I'm going to, prepare this piece here. It's a socket, Biltema socket, very low quality socket actually. And then I'm going to prepare, melt. Yeah, melt. I'm going to weld it into this over that one. At the moment it doesn't fit in there, but it will very soon. So I will now, just do some turning on it. And this is hard material, maybe, I don't know, really. Let's see. I'm going to use that one for my turning, I believe. So, yeah. So this is just, I'm eyeballing the suitable size there. Let's see now. There you go. Okay. Let's see how far I will go with it. Let's go that far, I believe. Yeah. Then it's there. So I have my carriage lock here. One more. So it doesn't. Where is it? Now carriage lock is there. Then my speed will be, well, it's now 800. Let's see how it is. And let's see one more time here. Let's see how it turns. Quite well. Where are those? Yes. These are really not exactly a life securance, but yeah, okay. Let's see now. Let's take a little bit. I will first take care of, there is a little bit. Oh, this turns really nicely. This is good material for turning. It turns like butter. Wow. Well, the other camera doesn't show it. It's not very nice. Let's see now. So let's try now that one. It might be a little bit better. So I will, the feed is about there. And let's see what I was last doing here. Okay, so I take like that. Too much. Well, the first ones I can do manually here. Okay. Yeah. This turns really nicely. So yeah, now it's let's take 0.5 millimeter out of it. Not 0.5 millimeter, 0.25 millimeters. And see how it reacts with that one. Yeah. If it fits there or not, I don't know. Well, it's not far. Let's take another 0.25 millimeters. Oh yeah. Yeah. Yeah, I'm running this dry because I'm going to thick weld this one. I don't want any excess oil into there. So yeah. And yeah, for the moment it goes really well. Yoo-hoo. No. Oh wow. No, yeah. That's it. Very good. It fits in there. Well, there is some rust in this one, this one, but okay. Now it's just to weld it. Ah, we have to shorten it because we need to take 5 millimeters out from the top. Huh. So let's see, change feed directions. Let's see which way this is. Oh, I think I can do it this way. This is on the way a little bit. Okay, let's see now. It's not better. Let's take a decent I have one that is proven to be good for facing cuts. It's the VNMG. It never lets me down. Let's see, how much was it? Steel? About, not that side. About 5 millimeters. So I zero the top slide, a scale. And I forgot my protective equipment. Where is it? Man, it's so easy to forget this. Yeah. They are not really comfortable. Okay, let's go. It turns blue, so this is somewhat hard. Okay, so 3 millimeters taken. 3 millimeters taken away. Well, there it is. I don't need to take any more of it. So, yeah. Okay, there it is. Like that. Yeah, this is really, I need to clean up this really well before. There is no crease, that's bad, would be bad, but I need to wire wheel it and then I just TIG weld it around. And you won't believe what is coming together, what is this going to be. Let's take this needs to be put low here in order to yeah, get it out from there. Then that one. Oh. It's still. There you are. It's like that. Very good. So, next, welding. Oh, yeah. So, let me set up these wires here. Oh, it was on. Shouldn't be. But it was on. 100 amps. And what's the mode at the moment? It's two-phase TIG. Very good. Let's open the gas. The argon here. Yeah, that's it. Well, let's see. Yeah, one thing about those argon bottles, when you open the valve, you should open it fully. So that it doesn't leak. It doesn't leak that much when it's fully open. And now, this workpiece here should be welded. Oh man, it's a long time since I last welded, so this might be fun. Okay, I see it. Here's my torch. And, well, of course I need to have my gloves. Oh wow. Fully protected. Wow. Yeah. Well, let's see how it welds. It might not weld very good, but let's see now. Man. Okay. Now, yeah. Yeah, it works. Let's see. First tag. Wow, it welds. And of course this becomes extremely hot. Whew. Next. There you are. I tried to blow away the smoke. You cannot blow because you have... it didn't make... No, it did. Okay, then I will weld a little bit longer piece here. This works quite well actually now. Wow! And the workpiece is becoming really, really hot. So, oh yeah. I need something because this is now becoming extremely hot. So I need something to move it around. Probably something like this. Let's see now how it looks like. Well, the weld is actually really nice. Okay, then that one. Oh, well, and the position is actually quite comfortable here. When welding, you should take care that your position, you can lean your hand on something, etc. with TIG. Because, well, otherwise you don't get it right. Okay, let's see now. A little bit more. Oh, whoa, whoa, oh. Dipping the torch isn't an option here. Oh man, what did I do? Oh well, I have a nice ball of... okay. Should I? Yes, I should actually. Man. These always go wild. So you should actually, when you grind it, you should grind it this way, so that not this way, this way. Oh yeah, okay. I should try here first the actual iron out of it, because we have a lot of that there. Okay, so this is CBN wheel, and it works really well with these. Oh. Okay. Yes. I need to get used to this equipment. It's really funny. Okay, let's see now. That one a little bit away, and then I will weld there. Okay. Let's not dip it. Let's not dip it this time. A little bit more, like that. Okay. Now we go. Yeah, way better. Okay. Then we need just a little bit more. No, quite a lot more. There you are. Next step. Oh. Yes. Okay, that's the last leg now. And this material welds really well, actually really well. So yeah. Oh. Oh yeah, it's done. Yes. Oh, this is becoming really sweaty, this helmet. And yeah. Oh, this is. But yeah, I hope we got it right. Where should I put these gloves? Not on top of the VFD. That would be a really bad mistake because it will block the ventilation holes, and after that it will overheat, and after that you don't have a good VFD. Okay, let it now cool down. Let's take these away while that welder is ventilating itself. You need to have it connected while it's blowing because it wants to get cooler. And this is there. Why doesn't it want to? Because it doesn't want to. It wants to go that way. Okay. Yes, there you are. And that is scalding hot. So let's. Well, I let these things cool down, and after that I wire brush it, and then I take some photos and show you what is this this thing for. Okay. So, well, let's see how hot this still is. It's well, you can hold it. Okay, and now I will wire brush it. And now this one on. Yes, and the protective eye goggles are really a must here. Let's see now. And no gloves here. Really no gloves. That would be. They are not very good at this point. Huh. It looks really nice. A little bit more there, maybe. Just. Well. Let's switch that one off. And what is this for? Well, here is a half-inch BSP tap, and I didn't have a big enough wrench for this one, so this one does the job. Yeah, and it's pretty decent. It doesn't wobble too much. Okay, and then of course I can have wherever that is. I have some. Oh, there it is. I have this, and I can have this here. And now I have a wrench for my tap. So why this? Why wouldn't I just take adjustable wrench and do it? No, that's not very good idea, because it will bend the tap sideways. And well, this is big enough, it doesn't break, but it will the thread will not become straight. It's quite impossible to handle. And again, this is too big to be done with power, under power. So, yeah. So that's the reason for such a thing. So let's take this one away. And then I also have here. This is a very nice drill because you can detach your chucks like that. It has a mechanism here in the side to do that. Okay, so next step, I'll present the material to you and of course the working drawing, so we can start milling the thing, actually. Okay, till that, and it will be very soon. So, Next step will be to mill a quite huge block of material to correct dimensions and make it straight. Oh, wait a minute, I have here the drawing, and it should be, oh well, wait a minute, 80 times 120 times 40 millimeters. Okay, let's put this document here. Yep. So, and the material. This is huge block in a way. It's like that. Yeah. So now I will first mill one edge straight. I will use this one to put it straight into the vise. So I will put it into the vise. We need to go lower. Okay. And then I have these copper sheets to get it there, so that it, because this is a rusty surface, yeah. So, and then I tighten it just a little bit. Okay, that's enough. Oh, this has a magnet in it. So let's see now. I want to calibrate it like that. And then I would like this to be about straight. It's quite straight actually. Already tightened too much. Okay. There. Okay. And I'm sure it will stay there now. Yeah, okay. Let's switch that one off. Okay, and now I just, wait a minute, speed for this one. This is a cutter that might just be able to cut the whole width, hopefully. How much should it be? Let's see now. The high speed for the first, and then this will throw some oil. I need to prepare for that one. Yeah, it did. Let's see about the speed. It's 500 now, it's too much actually. Let's put about 400. That's about okay. And then I go fishing, really. Let's see about the highest spot there. Well, yeah, this can manage the whole surface. Good. It will throw some chips now, so I need to be really, really careful. Where am I? Okay. I will use these, although these are not safety goggles. Okay, that much now. Okay, now it touches. Let's see. I think the fishing phase is complete. So now I go here at the end, and this can be run quite fast, the feed I mean. It can be quite rapid. Let's see about that. I will put it about 60 millimeters per minute, like that. Then I zero my set scale here. How much should be? This cannot handle too much. So I take 1.5 millimeters now. 1/3 in this handle is 1.5 millimeters. Okay, let's go. Okay, that's not good. That's not good. We need to lower the speeds. Quite a lot actually. It doesn't like me for some reason. 200. And this one should be also a little bit slower. Let's put half that, a little bit less than half, and then we go. Let's see what happens. Yeah, it helped. Of course, the surface finish is not as nice as it was earlier. Let's put it here now. Some smoke here, but this ventilator will pull it out from here. There, 60, it was about there, and then I take only half a millimeter. That should be all right now. Let's see. And now it should produce a really nice surface. Let's see whether I can use my noga for that one. Yes, I can. Good. A little bit was left in the... Oh man. And this time I don't need my spirit level. Spirit level. Yeah, okay. Let's pull it out from there. Yep. And then I put it this way there. So let's see. I think here is our highest spot, right here. Yeah, as you can hear, as you can't hear, it lowers the noise down. So, it was now 0. I think I go here 0.5 millimeter steps manually. It's the last pass. And it will be 0.3 millimeters, the depth of cut, and I will also speed it up a lot. So let's first adjust this one. So it would be something like 400 at that region, okay? Now, so, and then 0.3 millimeters here, like that, and then the feed speed, at the moment 30, I lower it down to 20. This should give us a decent surface. Should I do some smoke here? Yes. Let's put it there. Now it will smoke like a lot. There you are. Wow, really nice surface. Good. And yeah. I will come back after I have cleaned up this mess, and I will change another type of a cutter here. It will be a roughing end mill. I will do the ends of this workpiece next. Oh yeah, okay, so I promised that I have a roughing end mill here now, but I don't. Well, I will first take care of these flat surfaces here. Take the rust away and nothing. Now, yeah. Then I just do some fishing here. Well, these are definitely cutting. Now I wipe off this rust. We don't get any more rust, so yeah, good. Well, the finish is because of my very fast feed, so therefore it's not very good. It's not good. That should do it. It can. Okay. Yeah. Okay. I think I can speed it up a little bit. So let's put the high gear on, 60 millimeters per minute. Yeah, that's better. Decent chips and not dust. Okay. There are still some scratches, but I think I can get rid of those with orbital sander. Yeah, okay. Well, I'm not satisfied with this surface finish. This is really, actually it's quite bad. So what I decided to do is to use my Wollhauter as a fly cutter. Yeah, this setup is, let's turn it a little bit so you can see it. there is this, it has all sorts of extensions like this. You can actually have it out, even out here, to do what you want to do. But this is enough, so I can wipe the whole surface in one go. That's my goal here. And I hope it doesn't scratch on the backstroke too much. So, yeah. And I'm going to add cutting oil to it, because I suspect it benefits from this. Okay? And furthermore, I'm running this 100 revolutions per minute, not faster than that. Looks like this. And my feed rate is 17 millimeters per minute, not too much. And the cut of depth is 5/100ths of a millimeter, not more than that. We shall see what it starts to look like. Stop it carefully so it doesn't scratch anything like that, and then lower the table. And now let's test it with a finger. Wow, this is absolutely gorgeous, and it's straight. So, okay, I finished this side. The back side here, well, but we still need to do this side, and the final length of this should be well, 120 millimeters, and now it is 145 maybe. Let's put 120 here and see whether we have room for yes, okay, we can do it. So now this is a roughing end mill, and it will actually be capable, it would be capable of taking the whole 20 millimeters in one go, but I will peel off only 2 millimeters at a time at first. And yeah, I have locked the table, and I'm running this about 200 revolutions per minute. And this definitely needs cutting oil. It doesn't run without. How to fit this? This bottle is slippery. I definitely need some new patent to this one. Okay, let's go. And this eats really happily, this metal, so it's really good. And this was not 2 millimeters, it was less, definitely less. Again. 134 millimeters. Oh well, and ventilation is needed here. There is some smoke. So Oh yeah. Well, I'll come back when I have finished this one. I need to take a few breaks when I'm doing it. It's a very heavy turning because this doesn't have the machine feed to that direction. And yeah, so we'll see you soon. Well, after this pass, there will be 0.5 millimeters extra. And I will use that 0.5 millimeters to finalize the surface here. But first, let's take off that. Well, I decided to take shallower cuts. They are much faster to make and don't need, they are not such an exercise. Yeah. Maybe. Oh, this roughing is now over. It was quite quite an exercise. Yeah, okay. So next step, I will change that end mill to something that I can use to Is it hot? Oh, it's hot. Of course it is hot. Man. Yeah, it's really hot. And how come it's really clean? Oh, man, look at that. Huh. Yeah, and hot. Well, let's see. First of all, it should be like that, maybe. Then I touch it, lock the table a little bit. This is moving really easily, and I should hear. There you are. I will get rid of those as well. The chip that end mill produces are really horrific in a way that they are needle sharp and they are long, and well, this type of end mills, when you are doing side milling, they always produce well, very uncomfortable chips. So let's see now. Let's assume this is our 0 now. We have 0.5 millimeters. I'll take only 2/10 first, like that. And now we need cutting oil. Oh yeah. I'm using the same speed here, which is 200 revolutions per minute. And this one really likes cutting oil. So let's go. This should be a lot easier to turn. There you are. And now I will also come back. This is a climb cut. And why? This is because this end mill actually flexes. So when I now come back, it will cut the bottom a little bit more. Not a lot, but it will cut a little bit more from there. Let's brush this a little bit. Like that. Well, let's measure it now. Well, the surface finish is no more rough. It's very good actually. So, .3. Yeah, 120.3. As it should be, because I take 2/10 out of it, so yeah. So 3/10. No, okay. Let's go with that. 2, 3. There you are. Now it should be. This should be our final cut. Final cut. Is that some musical thing? Yes, it is. I think the final cut, final countdown at least, exists, but final cut, I don't know. Let's see, now we go. The last milling process for this side. And yeah, that surface is probably really good. Let's see. Wipe it clean. And not a lot of burr in that corner. Yeah, it's decent. So, that was milling the sides, and this stuff is really horrific. You have to be very careful not to touch these chips. They make your living a nightmare. They go into your fingers and then you cannot see them. They are there, but you don't know where they are. Let's see now. Well, maybe it's not a good idea to wipe this clean with a rag, because this rag becomes trash right away when I do this. But okay, it's clean. Oh yeah. Now, well, next step seems to be 6 holes. And I need to measure that corner. There is this corner. I need to measure the place. It will be my origo. So every measure will be taken from that corner. And I will do the bottom side first. So I'll do some setups here and then I'll come back. Okay, so now the next step is to set up the origo in this workpiece so that my working drawing so that it's easy for me to use my working drawing. The easiest way is to set up the origo in this far top right corner here. So after that, all the scales here under and there under and my scales here match so that 0 is actually 0. And advancing makes you advance also the numbers in the scales. And here are some chips. Okay, a lot of them. well, improper cleaning, I believe. So, I'm using this Haimer 3D device for this alignment. It's very easy to use. It has this small ball here, which if you move it like this, the Haimer needles also move. And it doesn't, it's independent of the direction of movement, as you can see. Therefore it is 3D. It's also up and down, which I don't use in this case because I don't know the exact heights, etc. But you could probably use it for, in some cases, you could probably use it that way too. So now my next task will be to set up the zero here. And I start with, here also the scales have a lot of chips. So I start with the Y scale. So when I move it like this towards the ball, now as you can see the needle started moving and our 0 point is up. I need to watch it like this, up in there I think. Okay, now I lock my x-axis to that. And I will do it also this way, always on the same way, so that I know which way my backslash is. So now when I should show this to you. Yup. So now when I zero my scale here, this is the scale, with this screw you can lock the scale. And then I just move this to 0 like that. Hopefully you can see it, and after that I lock it in place, like that, just twisting this a little bit. Okay, and well, now the Y is set. Okay, I can well, it's not totally set. I almost forgot. So there is also a more quartz scale here under. I need, okay, it's on 5 now, and that's it. So I can pack it off from here, and then I move, next I will set up my x-axis. So I go there, and then here, hopefully this is still on the frame, yes it is. And now I just move my x-axis nearer and nearer, so that, and yes, okay. The x-axis in this milling machine is like, it's really sensitive. So when there is this handle in this crank, it will actually move the table because the crank weighs that much that it can move it. Especially when the milling machine is running and it's vibrating a little bit, so then it does it every time. So the remedy for this one is to lock a little bit the table. So then I can do this adjustment reliably, and there you are. X is there, and now I will actually do the same procedure here. Same procedure every year. I usually do this with 2 hands. So I set this up to 0, like there. Yeah, and here also we have a locking mechanism. So now that one doesn't move. Yes, it moves, but it doesn't move in relation to the crank. And then we also here we have a scale, quartz scale, which I will, in this case, so that I can see it, I put it on 20 maybe, 0, 10 is right under this one and I cannot see it properly, so 20 might be good. Yeah, there it is, 20. So, oh, well now the corner is set. Now it's on 0, 0. So, oh, now the next step is to take this Haimer away from here. And well, it's really easy to drop this one. And this, wait a minute, here. This needle here is really sensitive. The red part here is not metal. There is no metal inside. It's, I think it's like glass, something like that. So it breaks very easily. It's intended to break easily so that if you drop it, so it doesn't hurt the mechanism inside, it just breaks the needle. You can get spare needles for this one. So I'll put one thing here which is sort of funny. It's every CNC user knows what this means. So you have to take it away very carefully from the... And yeah, this one has a 20 millimeter shaft. There are versions with this SK30 taper, etc. But I chose this one because it's, well, it's easier for me to use. So now I put this away carefully, so I don't break the needle. It's so easy to break it. So now there is also this collet. Okay. So now we have set the coordinates, and the next step is to start reading our document. Okay. First that I will do first are the well, the holes for these M8 threads. They are 30 millimeters deep, and well, M8, yes, M8, I think it was 6.8 millimeters, the correct. Let's see what it is. I'll take my camera with me and let's see about that. So here we have M8. So here is the drill size. It's 6.8 millimeters. And since this drill is 6.8, you cannot use a 6 millimeter collet with this one. You have to use a 7 millimeter collet, because it cannot be smaller, it must be larger or same. Okay, so I get another collet. Well, here is a 7 millimeter collet. So, okay, and these are really easy to use in a way, but they are not also easy to use, depending on what you think, how you think about it. So it feels loose now, and the correct depth to put it into there is so deep. Not so much, not so little, all the even area of there. So I always do it in a way that I take the drill in my fingers like this, and then I put it into collet, and then it's automatically on place. Yeah, it tightened, which is very good. And this is on low gear, so I can turn it. Yeah, there you are. Well, now I'll drill, well, 3 holes 30 millimeters deep. Okay, so now Now I'm starting to drill these, really drill these holes. I have already located the first hole here using my fine scales, etc. So now, this is 6.8 millimeters and it will go 30 millimeters deep. Need some cutting oil. Oh man, it will be some chips coming out from that. Let's see about the speeds now. I'm going to feed this manually. Well, now it's quite slow. It's really slow. I have another power switch here. I quite seldomly use it. So, high gear. Around 500 revolutions is good. Maybe a little bit more. Okay, that will be. And then, well, it will be. Each turn is 1.5 millimeters. 2 turns will be 3 millimeters. So 20 turns is our thing, and now I'm just trying to get it in touch with the metal. There you are. I will actually zero the scale one more time. Okay, now, and I will be counting this in Finnish, so you might learn something here if you want. So 1, 2, 3, 4, 5, 6, 7, 8, 9 ja 10. Se oli 11, 12, 13, 14, 15 ja nyt 16, 17, 18, 19, 20 ja se on 30 milliä syvä reikä. Asia selvä. Selvä. Ja näissä laseissa on jotain ihmemäälä. These glasses are not clean. So, näissä laseissa, these goggles, on jotain ihmemählää. Have some strange stuff on them. Okay. Second Finnish lesson. Okay. Not much better. There is still a spot. Okay, better now. So, our first hole is there. Next hole. Yeah, will be. Where should I go with this one? So 45.5 millimeters. Yeah, 45. So we have, here was the number 5 was the origo, 45. 10, 20. 95 is, there. Now, sanity check. Oh yeah, now it's better. Now it's perfectly on top. Okay. So, next hole, really. So, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9 ja 10. 11, 12, 13, 14, 15, 30 millimeters deep hole. Hopefully I didn't count it wrong. Is all the way there. 100.6. Yeah, this way, X direction. 100, like that's 100 and I need to, okay, it's there. Yeah, change the glasses one more time to proper safety goggles. And then we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 ja 20. Okei. Noniin. Sitten mun täytyy vaihtaa siihen toisen kokoinen pora.
Niin.
Nyt me vaihdetaan siihen seuraavaksi 8 mm pora, jolla tulee ne.
En haluaisi porata.
Siinä tulee yksi reikä, joka on 8 mm. Tähän on merkitty, että se on 40 mm
Okay.
syvä. Mutta mä palaan asiaan, kunhan mä saan poran vaihdettua.
Lähes läpi asti.
Did I speak Finnish all the time? Man, let's take this again. So now the holes are drilled, and we need to drill a hole of different size next. So what I will do now is that I will change the drill and come back after that. Wow. Oh yeah. Now I have a 8 mm collet here. You can read it there. Maybe there, yeah. And well, 8 mm collet and 8 mm drill. And then I will put it there. So about these collets, well, in Finnish the name of this device is kiristysholkki. So 45, yeah, 45.3, 45. With this, let's see that the hole is where it should be. About, yeah, it is exactly where it should be. Yeah, good. And we can drill this with same parameters, same speed, same feed. So I leave it there. So 30 millimeters, so 20 turns on the crank. Okay, let's go. Okay, and now, oh yeah, now I will change another drill. It will be 10 mm drill this time. So 10 mm collet, 10 mm drill. Is it? Yep. Okay. And the first one is x-axis seems to be 62.5. So 5.5. Okay. Sanity check. This is like that. It should be in the middle of the big hole, and it is nicely there. Okay, and this will be 15 millimeters deep. Okay, but I will slow it down. Slow it down a little bit. About 400 revolutions per minute, and then I touch it. So, oh wow, X-axis is 77.5. So 7. that should be it. It looks like it's on the place. Oh, my Schaublin went flying. Yeah. This is very important to do this every time. Okay, seems to be in the correct place. So now, yeah, should I count in Finnish? Yes, of course. Otherwise I will go haywire with my count. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9 ja 10. That's 15 millimeters deep. Very good. Very good. Okay. We are done with the holes in this side. So the next thing will be to chamfer the M8 holes, the 6.8 millimeter holes, and then tap them. Yeah. So this is a Dormer 19 degrees chamfering tool. So 45 degrees per side, so therefore 90. And there is a suitable collet here. 12 millimeter, I believe that was. Oh. And then this is not to be run very quickly, so it has to be run not that slow, but now that's okay. About 120 revolutions per minute. And I'm going to do all these holes. Some of them get a deeper chamfer and some of them shallow. There is one specially, this 8 millimeter hole. This one which should be a little bit shallower. But let's start with the first one. So I'll go them along the x-axis. So 17.4 millimeters is our first. So 17, that's 15, 16. Yes, it's better, a lot better. Okay, we are done with this, and the next step I will set up tapping equipment here. Now I will tap 3 M8 threads into this workpiece. I have filled the holes with cutting oil. And this is a spiral flute tap. Yes, I did clean up this workpiece and deburred it really carefully so that there are no burrs anywhere at the moment. And yeah, so I had to take it out from the vise and flip it. So now I slide it against my Haimer. The table is now at 0 position. So when I get this into correct place, which is oh, not that much. Oh, there. Ah. Yeah. So there it is. It's now 0. It's in place. Quite exactly, actually. So, yeah. So the y-axis was already done because it references the fixed jaw of my vise. So now we have here a 6.8 millimeter drill. And why is that 6.8 millimeters? Well, it worked so well last time. So that's the reason, the only reason. So the first hole will be, the X direction would be 45.3 millimeters. Okay, I think I need to switch this machine on. Like that. And then we need some speed here. It was around 500 last time. Like that. And then I have my 0 here. There it is. Okay. One last check. So 45.3. 45.3 around there, and this should be that direction. At least it seems like 40.8, almost 41, so from that direction, well, it's about there. So now let's go. I'll drill it now. First hole is there, and it's a true hole actually now. And what I could feel, it's really in the place, in the correct place. So the next one then. Okay, these are fine. Next one, 74.5 millimeters, the X, and now 0.5 more. Okay. And this I will drill at least 20 millimeters, maybe more. 25 I believe is a decent amount. Now, next drill will be 19 millimeters. Yeah, 19 really. So I will change the equipment here one more time and come back after I have done that. Okay, 19 millimeter twist drill, turning 170 revolutions per minute. And I need safety goggles, and let's first touch, because now I'm going to use power feed here. There you are. And I'm going to count these. Okay. And the slowest possible. There you are. There you go. Now, let's take it one turner at a time. it starts cutting the chips because we have reached the other hole there. It's on the side, but nevertheless we have reached it. So now it's 26 millimeters from the tip of this drill. So yeah. Wow, a lot of these. So yeah, okay. So now the next hole. Well, it's just drill. Here we go. And yeah, okay. Okay. This is now the last big hole. It will be 15.25 millimeters in diameter and well, 30 millimeters deep. So let's start with this one. I touch it first again. So here we are. Okay, next I will chamfer these holes. Well, okay, I said that I should use this one first, but I decided not to. I will do very carefully the first few turns with this one so that it starts straight. And I know that it starts straight when I have this pin there in place. So now I just have some cutting oil here and really try to twist, not to twist it too much. This can be hard to turn. Okay. Well, it's not a dull tap, which is good. There you are. I think we are done with the first few turns. Maybe I can take a little bit more. Not more than that. Okay. Now I change the tool to that thing. And the reason why, there is also one more reason, I'm running out of travel in Z direction. That, okay, now it is there. Now it is there. And I can do the heavy, oh yeah, heavy turning with this one. This is the type of thing it will be housing. It should go there, yeah, okay. And it should go all the way. Okay, it does. So now this is the last step for this hydraulic block, and it is to mill holes that are not straight, they are in an angle. So what I will do, I will put this workpiece in an angle like this. So I will use this thing for that. I first calibrate it here like that, and then I put it here, and then 22 degrees. Oh man. That's close enough. Okay. So now this is in an angle. When I poke through there, it will actually go into the correct place. But first I need to adjust the y-axis. It is in this case. It's the part of it is actually 55.5 millimeters. That's 55. That's 55, I believe. Yeah, 0.5. Like that. Now it's in the middle of the hole. And next step will be, this is eyeballing really. You cannot do this. Well, you could probably have some measures in your drawing calculated there, but I think that's close enough. And now when I poke it there, it should do its job. Man. And I'm running this apparently almost 600 revolutions per minute, so quite fast. This is just a touch and feel thing. And I definitely need these. And yeah. So it's a little bit horrifying, I can tell. So then we go. Oh yeah, but we have a hole there now. Let's see what happens. It should actually be better now. So we can go quite fast there. Okay, there you are. Now we will see what kind of a hole we have there. It should be wide enough, it should be so that the oil has a passage to go. Oh yeah, it looks really nice now. Oh yeah, now we have a hole there. A really good one also. Let's blow the chips away from there. Now we have a good, very good hole in there. Yes, nice. Well, we already have a decent hole there. We don't need to do anything for this one. Okay, this is already like a good one. Man, you know what? This is this workpiece is now. I just clean it up and then I make a call to my friend Fredrik, not Fredrik, Robert, and tell him that he can fetch this. He's living about 500 meters from here, so he might come quite soon actually. So this is probably good news for him. I just clean it up now. Ei se tän kummempaa. Taputuksia, että saa äänen synkkaa. Joo, tämmönen siinä tuli.
No niin.
Mä tiedän, joo. Mikä se nyt sitten lopulta on?
No se on traktorin jarruventtiilin niinku lohko, mikä niinku se venttiiliin tulee kiinni.
Joo, okei. No tähänhän tulee näitä kaiken maailman. Tähän tulee näitä tämmösiä öljynäppylöitä. No niin, se on just väärinpäinkin vielä siinä. Hopsis! Joo.
Eli siinä tulee niinku...
No, kerro vaan.
Lohko, eli se venttiili tulee niinku tänne puolelle.
Joo.
Ja tää palikka, mitä sä oot tehnyt, niin se on pelkästään just, että mä saan nää letkut kiinni.
Joo, ja tohon tulee sitten tommonenkin.
Joo, eli siinä tulee 3 hydrauliletkut.
Joo.
Tulee...
Mitä se itse asiassa venttiililohko, niin mitä se tekee siellä?
No se on peräkärryn jarrut.
Se on jarru ihan vaan?
Joo, että siihen tulee se venttiili, niin siihen tulee jarrupaine niinku, ihan jarrunestestä. Joo. Jarrupaine ja se venttiilistä, niin siihen tulee myös hydraulipaine. Ja
eli se jarrupaine avaa sen...
nimenomaan.
Avaa sen venttiilin.
Avaa sen venttiilin ja se antaa hydraulipainetta.
No, se on jonkinnäköinen semmoinen säätyvä venttiili sitten, että muutenhan se olisi aina paniikkijarrutus.
Joo, nimenomaan. Just sen takia se riippuu kuinka paljon jarrunestepainea niin tulee.
Niin, eli se on semmoinen jonkinnäköinen...
Tulee niin.
No niin. No, semmoinen siitä tuli.
Kyllä se hieno on.
No, siis... nuo kierteet on ihan niinku hirveitä tehdä. Kato, mä tein siihen oikein tämmösen adapterin.
Yes. Kyllä.
Kuule, tikillä vetäsin kiinni tuosta ton ympäri, että saadaan se. Nimittäin noitahan ei parane niinku jakoavaimella mennä hirveästi ainakaan kääntämään. Että kyllä mä jouduin starttaa. Tuosta loppu korkeudesta varat kesken tuosta jyrsimestä.
Joo.
Niin mä jouduin sitä sitten sen kanssa taistelemaan, mutta ei siinä mitään. Loppu hyvin, kaikki hyvin. Sit mä suosittelen kyllä ton kanssa, että kannattaisi ehkä, niin varsinkin tälle puolelle nää, niin mä laittaisin niihin kyllä jotain niinku Loctitein tiivisteitä.
Joo, laitetaan.
Mä voin antaa sulle mukaan ton purkiin. Onko se samaa?
No, en tiedä mikä sama on, mutta se on tommonen...
Se väri on semmonen mukava vaaleanpunainen.
Se ei oo pelkästään... Joo, no se on keltaista se mikä mulla on. Mutta se on niinku hydrauli just nää jengoja.
Eli se ei niinku...
Se ei oo pelkästään Loctite.
Ei, joo, ymmärrän, mutta siis et se ei oo semmonen... Se niinku kovettuu ilmattomassa tilassa.
Joo, niin varmaan.
Joo, ja liukenee öljyyn muuten. Joo, kato, siinähän on just se, että toi on nimenomaan semmonen, että se kun joutuu ilmattomaan tilaan, niin se kovettuu. Ja muuten se ei kovetu, ja sitten se ei kovettunut versio, niin liukenee öljyyn, että se ei muodosta kökkäreitä. Joo. Siellä on kuule vinot reijät sisällä.
Joo.
Ne oli ihan fiksut.
Onko toi löysä toi pala, mikä tuolla?
Mikä ihme löysä?
Eikö siinä tommoinen? Näkee.
Joo, ei se mikään löysä ole.
Että se ei ole...
Se on reijän pohja, siellä on vinoreikä sinne...
Joo, se on sen takia vaan. Se
niin, joo. Sitä joutuu kuule miettimään, että miten ne reijät tehdään niin, että siinä on riittävästi sillä öljyllä tilaa kulkea kanssa.
No joo, se on.
No nythän siinä on.
Tää on niin
joo,
se melkein
joo.
Se pienin kohta.
No nyt jos sä ajattelet sitä, että se on jarru, niin siellähän ei ole mitään hirmuisia liikevaloja missään.
Ei, mutta koko hydrauli, niinku, kun tulee pumpusta, niin se tulee suoraan tänne läpi, ja että se menee koko ajan tähän läpi.
Se kiertää
sitä. Tää on niinku ensimmäinen se sarjassa. Sitten tulee niinku seuraava.
Joo, okei, no sittenhän...
Joo. Että täällä on pakko olla niin kuin ensimmäinen, koska täällä pitäisi aina olla
Joo,
riittävästi.
kyllä. No niin, mutta semmonen siitä tuli.
Joo.
Toivottavasti nyt sitten, tää oli tää sabluuna, millä mä tein sen.
Joo.
Eli mähän otin tästä valokuva.
Okei.
Mulla oli siinä millimetriviivaa vieressä ja valokuva päältä ja sen jälkeen CAD. Mulla on semmonen kuin FreeCAD, joka on ilmanen ohjelmisto, jolla noita voi piirustella.
Mä kuuluu, että se on...
Joo, niin sähän
saat
työkuvatkin mukaan siinä. Olepa hyvä. Joo.
Mutta se menee niinku, pystyy se niinku muuttaa se skaala.
Joo, kyllä. Eli se tapahtui niin, että siinä oli se viivain.
Joo.
Niin mä ensinnäkin oikasin sen niin kuin sopivasti siihen. Ja sen jälkeen mä katson, että no viivain näyttää 10 senttiä tossa. Ja kädissä se väli on kuitenkin niin kuin 7 senttiä. Niin siitähän saa laskettua kertoimen.
Joo. Nimenomaan.
Joo. Joo, kyllä ne...
Mietisin vaan, että jos mä ottaa niinku kuva, niin siitä, niin sit sun pitäisi kuitenkaan ottaa ne mittat, että sä saa se oikea...
Siihen täytyy saada rinnalle viereen joku mitta.
Joo, nimenomaan, koska
niin.
muuten se kuva
Joo, mulla oli toi suorakulma siinä vieressä, toi on keltainen pohja ja mustat numerot. Se oli siinä vieressä. Se riittää, vaikka se tarkkuus ei ole mikään kummallinen. Mutta kun siinä on riittävästi sitä mittaa, niin se... Ja näähän ei oo, no noin saattaa noin M3-pultit olla silleen, että jos siellä on jos ne on millisivussa, niin sit saattaa tulla ongelma. Toivottavasti ei. Niissä pitäisi olla 25 milliä kierrettä sinne sisälle.
No.
Ainakin. 30 mä yritin, mutta en mä uskaltanut vääntää enempää. Joo. Ja sitten toi terässä niin osoittautui, että se ei olekaan mitään paskarautaa. Siis sehän oli yllättävänkin kova tavalla. Joo, no semmonen. Hyvä.
Hieno homma.
Pääset sen nyt sitten asentamaan sinne. Milloin sä menisit laittaa sen? Nyt? Okei. No selvä.
Kun mulla on kuivarissa siinä taisi homma mikä. Eikä se... No, mikä se nyt on?
No sano vaan ruotsiksi, jos ei.
No sortering, eli
lajittelee
niinku, vehnää siinä, niin se kone niinku, pitäisi olla kuitenkaan siinä koko ajan katselemassa tai vahtimassa, mutta just tämmöistä
pystyy tekemään siinä sivussa.
Joo, nimenomaan.
Joo, okei. Okei, mä jatkan syömistä, mulla on pikkasen vielä... mutta mä heitin tämän väliin. Selvä. No niin.
Kiitos.
Ole hyvä. Joo. No niin.
Palataan taas.
Joo. Katsojat varmaan olisi halunnut tietää, että minne se menee, mutta ne saa tällä kertaa tyytyä siihen, että mä en jaksa lähteä mukaan. Joo. Okei, hei, tää laatikko.
Joo, laatikko.
Siinä oli jotain. Siinä oli jotain. No niin. Joo, selvä. No niin, hei hei.